Okay, so we start chapter 3, which is about retail sales. What is retail? Retail is when you sell something, but there are two types of selling. One is the wholesale, bil jumla, I think this is called, and the other one is retail, which is bil qata'i, I think. Okay, if I'm wrong. So retail sale is like the sales which are in the baqalas, like, okay, you go and buy one thing one by one. On the other hand, the wholesale is when you go to big shops and you buy bulk of things, many things at the same time. So this is about retail sales. So a retail sale is actually, identified by a point of sale, which we call it POS, point of sale. So there is a cashier, okay? People, when they shop anything, whether one thing or 100 things, maybe in a trolley or maybe in a bag or in a hand, okay, they bring all the things to the counter, checkout counter. There is a cashier. The cashier scans items one by one using barcode or whatever mechanism is there, okay? And then the items are collected in another basket or in the keys, okay? And the people pay and go. That is the retail concept, okay? So we are going to understand that what type of dimensional modeling can be applied to retail sales. So before going further, I would like to just discuss with you and want to listen your ideas about retail sales. Okay, we have already discussed the, in the exam, you had the hospital example. Okay, so that was a business perspective from a hospital. How do you do that? You did dimensional modeling. In retail sales, what do you think? Yes. So Nujud says that retail sales is the purchases of finished goods and services by consumers and businesses. Yes, finished goods. Finished goods are the things which are ready to be consumed. Okay, lil istihlak, qabil istihlak. Like this is not the raw thing. Raw, I don't know what is this is kham or what, but raw is something that is used to prepare other things. Okay, but finished goods are the final goods. So for example, when you buy milk carton, so it is finished because you just use it in your tea. When you buy biscuits, etc., so they are finished goods. Okay, so sale dimension. Now, what is sale actually? Asma, this is what will be the sale dimension. What do we call it a sale? Because the important thing first, if you see, we have four, we call it the 4 steps of business dimension. Okay, let me go back and open that. Where is that? The 4 steps. Yeah. So select the business process. So the process overall is known as the retail sale. Okay. And what is retail? That's what I'm asking. We will go to the dimension later. Just wait, Asma. But what is, the process overall? How does it work? I have explained it. Is there any other way that I missed and you can explain in retail sales? So these are the things in, chapter 3. We are not going to discuss everything. You mean something like scan barcode. Okay, that's one, that is part of the process. Scanning barcode, that is part of the retail process. Okay, so you scan. What happens when you scan something? We usually buy from supermarket, yes. But how does the process go? Okay, not from, so a customer goes and the customer gives all the products of the cashier scans. What happens in the computer, for example? In your opinion, what are the things that we record in the computer? It will store all details about product. Okay, which products? Like, is there one product, many products, are there types, and so on? This is important now, Asra. We are going to discuss this thing. Okay, so product is one thing. And then what else? So can we say that product is one dimension? The way to store the details of product. Okay, so is there any other detail than the product? So product will contain what? There will be price of the product, there will be a name of the product, there will be a company of the product, There will be a type of the product. For example, is it liquid product, or is it solid product? Is it gas, for example? There may be the category of the product. Is it from dairy? Is it from meat, luhumat? Is it from, mukassarat? Is it from something else? Okay, cashier info is something we will see. Yes, that's a different thing. That is not cheese. Yes, cheese is from Luban or whatever the category is that. This is from muntajat, what is called baqara or whatever you call it. So that's dairy. We call it dairy in general. Okay, dairy products. So cheese, milk, laban, yogurt, okay, all those things, they are in the dairy products. Okay, so it means that a product has a type. Then dairy product is one type of product or one category of product. And you have electronics product. Within the electronics, you have, for example, phones, you have laptops, you have tablets, you have cameras, you have projectors, you have washing machines, kitchen electronics, and so on. So electronics then becomes a department. There is electronics department, there is books department. Like Jarir, let's say, if you talk about Jarir, it is a retail store, okay, because everyone goes and buys one thing. It may be pencil, it may be a daftar, notebook, okay, so that's stationery department. Stationery is one thing, all related to pens and pencils, etc. Then they have electronics department. They have arts department, in which they may have this funun, everything. Books department, they have okay, what else can they have? Jarir, let's say, if we take the example, electronics is done. Within electronics, you have computers and all those things. Okay, so you see, a product itself is such a big concept. There are so many things, and we need to identify those things. Okay, that is actually the objective of this thing. So let's take the example of Extra or Jarir or Panda or Aswaq al-Uthim, etc., to model their business process. Okay, that's important thing, and you should remember this, what we want to do. Okay, so first, what is the business process? We say that a business process is a low-level activity performed by an organization. Low-level activity. Okay, it's not a high-level activity, but it's a high-level activity. A high-level activity is, for example, you say that Panda high-level activity is that it is selling things to the customer. Okay, Microsoft's high-level activity is that it is selling software. Okay, a petrol pump, a gas station, it is high-level activity is that it is selling gas. Okay, that is high level. But then in detail, like a petrol pump, okay, what is called the muhatat al-wuqud, okay, it sells what? It may be selling, let's say, diesel. It may be selling 91 type or 95. It may also be giving you, buncher service. Okay, it may also be giving you service for, oil change, etc. Okay, so there are different things going on, but we are talking about the low level, which means the details, okay, by any organization, such as taking orders. Now, taking orders is one thing. In the restaurant, you take orders. Invoicing means you generate fatura. So that is another thing. How do you generate your invoice? How do you create that? Receiving payments. How do you receive payments? Why is it a business process? Can there be any things in receiving payments? Receiving payments can be what? It can be you receive cash, you receive shabaka, okay, by credit cards, you receive by ATM cards, or maybe some other things. Okay, handling service calls. Handling service calls is what? It is telephone calls related to your products, for example. Okay, so let's say in a hospital, you have service calls for appointments or for results, for any other things. Okay, for a hotel, you have the booking calls. Okay, Hajj. For airports, you have some other information like what's the flight time? Okay, is the flight available? Is there any seat? Is it canceled? Is it on time, etc. Registering students, think about that. We register students. That's a business process, low-level activity. Okay, registering for a course, yes. Taking appointment, yes. Registering for a course is a appointment. Taking attendance is also, a business process. Why is taking attendance important? Because it is useful in deciding, the final outcome, whether there is a herman or whether the student is allowed, for example. Okay, so these are different things. Performing a medical procedure, operation, amalia, all those things, they are business processes. Or processing claims. For insurance claims, for accident claims, okay? So claims is whatever you do when you have whether from your insurance company, is it medical insurance, whether it's you know, vaccine insurance, for example, or maybe it's about the car insurance, etc. Okay, so to identify your organization's business process, it's helpful to understand several common characteristics. Okay, so there are some things, for example, they are expressed as actions, action verbs: do something, buy something, sell something. These are all, you see, action verbs: receiving, registering, processing. So they represent what? They represent the business process. Okay, so they represent the activities that the businesses performs. And we will then, the dimensions will be, we will find from these actions. Okay, business processes are typically supported by an operational system. Okay, there is a billing system which will generate bills, or purchasing system which will say you purchase something. So that is operational system. We know about operational system, which means that it is part of your business operations. Okay, daily operations, coming in, going out, okay, buying, selling. So business processes, they have an operation system. Okay, like registering students, it has an operation system where you register for a course online and it is recorded. Okay, attendance is an operation system, because when I take attendance, it is recording in a system. It has its own page in Educate, in which I record my attendance of students. Then business processes generate or capture key performance metrics. Okay, what are the key performance metrics? Let me just highlight those things. Sometimes the metrics are a direct result of the business process, and the measurements are derivations at other times. Okay, so we will see the example of metrics, but for example, one is the metric is the attendance. The other metric is the credit hours, for example. Okay, how many credit hours is one course, which lecture number is there, how many marks of a student. Okay, the things that you sell, the things that the store sells, okay, and the price, etc. They are the performance metrics. Okay, we will see that. Business processes are usually triggered by an input and result in output metrics. Okay, so there is some input and output metrics. So what are the input metrics? For example, the input metrics is that when you scan something, so the input is a product. Okay, and what is the output? The output is an invoice, the bill, the fatura, that gives you output. So sometimes the input is not one thing, many things, because you scan too many products and at the end you get one output. Okay, but the output may be actually many things. So one invoice is not just one product, it contains a list of all those products and many other information. Okay, so that are some of the characteristics of the business process. So I hope you understand now what is a business process. So first, we select the business process. What is our business process? And that's what we hear. So you need to listen carefully to the business to identify the organization's business processes. Okay, that's very important. And here we mean that, let's say you are designing a data warehouse, dimensional table for a company, for any organization. Let's say you are the designer, you are the person who is doing that. So you need to listen carefully, okay, to identify their business processes, because business users can't readily answer the question, what business process are you interested in? Now, this is a very important point. Think about that. You go to a company, you want to design a data warehouse system with dimensional modeling for them. Okay. Now they don't know anything about dimensional modeling. They don't know anything about business process because they are not business persons. Maybe they are not educated, or maybe they are educated, but they may be physics, mathematics, okay, computer science. They may not know anything about business. Okay. So you cannot directly ask them about their business process, but you need to find yourself, what are the business processes? So the performance measurement users want to analyze in the data warehouse business intelligence system result from business process events. What is a business process event? A business process event is whenever there is some triggered as input or output. Okay, so someone buys one product, that is an event. Okay, a student passes an exam, let's say the teacher enters his or her marks in the system, that is an event. Attendance is an event. Okay. About hospital, a patient is admitted, that is an event. A doctor writes medicine in the patient's record and send it to the pharmacy, that is an event. A lab result is an event. Okay, taking sample of blood or urine from a patient, that is, these are events. So from these events, we will identify the business process. Okay. So it is also worth noting what a business process is not. Okay, what is not a business process? That is a thing you need to understand. So organizational business departments or functions do not equate to business processes. Now it means that if you count different departments, there is a registration department. Okay, there is what is called Amada Qabul Tasjil, for example. This is one department, but this is not a process. Okay, there is Amada IT for IT department. There is Kulia, so they are not your business processes. Okay, by focusing on processes rather than on functional departments, consistent information is delivered more economically throughout the organization. So we will focus on the process, not on the functional departments, not about deanship of research, deanship of admission, deanship of languages, and deanship of student affair, deanship of tadris, etc. No, we are not interested in those things. We are interested in the process. Okay, so if you design departmentally bound dimension models, you duplicate data with different labels and data values. So departmental dimension models are not good, not from the department, no, from the process point of view. Okay, that is very important. So we will select a business process. Now, as we said, the business process is what here? It is retail sales. That is our business process. So sale is one particular process. And we know what is sales, that customers come, they buy. Here was the definition by, who did the definition? Nujud, that the purchases of finished goods, and services by consumers and businesses. Okay. So let's say retail sales is our business process. Then we need to declare the grain. Okay. What does that mean, the grain? The grain means specifying exactly what an individual fact table row represents. Okay, we will define later about the facts, but in general, a fact table row, and we already know about dimension table and fact table. Okay, if you have forgotten or you're confused, no problem. By the end of this chapter, we will know exactly the difference between fact table, dimension table, and facts and dimensions, even inshallah, in more detail. Okay, so here, grain means what? Grain in Arabic is habba, I think. Okay, habba, which means the small detail. Yeah, level of details. The granularity is called, in English, it is called granularity. Okay, fine grain means too much detail. So how much detail do you want? At what level of detail you have this information? So that will be from your fact table row. What is your fact table row? That fact table row determines your grain. So it conveys the level of details associated with the fact table measurements. Okay, so fact tables have measurements. Remember this thing, measurements. Okay, measure means to, this is called what? Magas. Okay, measurement. So we will have those measurement in the fact tables. It provides the answer to the question. Remember, what's the question? How do you describe a single row in the fact table? Okay, so if you got this answer, then you have found your grain. Okay, what was the first one? The first question about business process is how things are going. Okay, this was the first one about the business process. What activity is being performed? Okay, what business process are you interested in? So we have this answer here, like what is the, how do you describe a single row in the fact table? What is there in a row? What is a row? So a row is one record, and a record is, composed of many attributes. So simply, we want to see which attributes are we interested for each record. Now you may know that in general, when you have a business process of sales, so by the end, the input is a number of items to be scanned by the barcode, and the output is the invoice, the fatura. So that invoice has what? It has details about what, which are the products, what was their price, how much was the quantity, and how much was the total bill, what was the time, who was the cashier, and let's say if there are many stores, which store was that? Okay, so that's also important. Now, single row in the fact table, we are going to understand. Okay, examples are what? One row per scan of an individual product on a customer sales transaction. Yes, that's clear. When you have your fatura, what does it have? It has each item as a single row. Okay, but let's say if you have 6 or 5 or 4 packs of milk, so normally they will not repeat, but they will multiply it by 6. In general, it depends. Okay, so they will say 6. Okay, sometimes they also have in each one repeated again, so they will say milk price, then next again milk, and then price, and so on. So it depends. There are some things which are there. Okay, we will discuss that as well, hopefully, that what's the solution for that. But normally you have one row per scan of an individual product. Okay, one type of product. One row per line item on a bill from a doctor. In case of a doctor, for example, okay, so it has an item, for example, medicine or lab test. So there is one row per line item. Then one row per individual boarding pass scanned at an airport gate. So the boarding pass is what you have when you need to go sit in the airplane. Okay, that contains your seat number, okay, your name, and the time of the flight, the gate number, etc. So the transaction system of the airport, that flying company, it will have one boarding pass per what? Per passenger. Okay, one row per daily snapshot of the inventory levels for each item in a warehouse. Can anyone explain to me that? One row per daily snapshot of the inventory levels. Yes. Yes. We are talking about daily. Okay. We are not talking about each transaction. We are talking about warehouse, mustawda. So it's like a company's warehouse from which things are gone. Okay. So what is one row per daily snapshot of inventory levels? What does that mean? Because we need to understand that so that it can work. Yes. Are you there or not? For reporting, yeah, you can call it for reporting, because at the end we have this thing, yes. Okay, at the end we have, you can call it reporting, yes. So what is the snapshot of the inventory levels of each item? Okay. Okay, let me explain this. Because data warehouse take once, yeah, but what does that mean, a snapshot? It means that it will, at the end of the day, actually, you have a snapshot means it records the state of the products, all the products. So when the store closes, for example, it will tell you that how many things, not a specific time, but at the end of the day, let's say, or you can call it specific time, but normally it's when you close the store. So it will tell you that today, okay, when we close the store, how many items are remaining for each type. So for example, how many milk cartons are there? Okay, how many packs of biscuit of these brands are there? Okay, so we are talking about warehouse, so it has usually big cartons. Okay, so how many cartons of these things are there? How many cartons of that things? How many kilos of this thing, etc. So this information is the daily snapshot. At the end of the day, you record what is, and the inventory levels are the things in your inventory, is all the things that are there for sale. Okay, so inventory level for each item. What type of item is it? Milk, which company milk? Okay, so you will store that, and that is actually the daily snapshot. So for every item, yes, in general, because in the middle of the day there is no need, because it will be changed after a minute or maybe after an hour, the status is changed. So normally when the business is closed, like when we finish the time, so we will have a snapshot of today's, remaining things in the market or in the soup. Okay. So the important thing to understand is that there will be one row for each item. Okay, like milk of al-mara'i will be how many cartons, milk of asafi, how many cartons are remaining, and so on. So that will, for each type of item, it will record the total. Okay. Well, actually, that's interesting. When we have, automated system like a transaction system, so as the customers, they buy things, so automatically it is, removed from the inventory. So at the end, it is automatic. Okay. Uh, yeah, example grain, yes, a boarding pass, which is there. Nujud, it's there in the third column, that this is a boarding pass. Okay. Okay, so one row per bank account each month. So at the end of the month, each bank branch, for example, okay, they will tell that what is the account status of this user. So let's say there are 100 accounts in a branch, okay, in a bank branch. So at the end of the month, they will generate a report that this account has this much money and the other account has this much money. So they have the total, but at the end of each month, for example, not every day. So some things, they are like daily basis, sometimes it may be weekly basis, sometimes it may be monthly, or in some cases it's even annually. Okay, like there's bank annually, they do it annually. The bank do this thing so that they can see what are the changes in the accounts and so on. Okay, so we express these grains in business terms. Okay, what does that mean? That although the grain ultimately is equivalent to the primary key, it is a mistake to list a set of dimensions and then assume the list is the grain declaration. Okay, we will come to this point. It will be explained with the help of an example. Okay, so, but the thing is that we should express the grain in business terms. Okay, not in the technical terms. Business terms means what? Like, for example, how many units are sold, how many laptops were sold, for example. Okay, so this is number of laptops which have been sold. That is the business term. Okay, now the most frequent error is not declaring the grain of the fact table at the beginning of the design process. So that will be an error. We should declare the grain of the fact table. If the grain is not clearly defined, the whole design rests on quicksand, which means it will be not a good design if we do not describe our grains. Okay, so identify the dimensions. After the grain, okay, of the fact table, we will identify the dimensions. Dimensions fall out of the question that how do business people describe the data resulting from the business process measurement system. Okay, so we are again dependent on the business people. Okay, how do they describe the data? Okay, and what are the business process measurement events? We should know that. Okay, so whenever there is some event, how do business people talk about that? In case of retail store, for example, they will say that these many items have been sold. So sold means selling something. Okay, and the quantity is that thing. So that is the dimension. If you are clear about the grain, the dimensions typically can easily be identified as they represent the who, what, where, when, why, and how. This is interesting. So the who, what, where, when, why, and how, these are WH questions, 6 WH questions. They will tell you the dimension. For example, who will be what? It will be cashier. Or if you have like a loyalty program in which you have cards, for example, a lot of them, they have the Iktisab card. Okay, so the Iktisab card is for if you want that, you will have, or the Shukran card from Max and Center Point, etc. You have those cards. Okay, so the card represents who, because they will ask your mobile number, and when you buy something, they will give you points in your account. So the who is important from the customer point of view. But in other cases, normally, like in simple maqala, the who is not important because they don't care who is buying. The only who there, which is important, is the cashier. Okay, so that they know who has sold something. What can be what? It can be the things. What things have been sold. Did someone, sell like milk or toffees, candies, biscuits, okay, and electronic items, other things. So this is the what. Where means like which store. For example, even in Taif, we have two bindouts, right? So which bindout you are taking from? Or max, there are 2 or 3 max here, and so on. When is the time? Okay, it can be date, it can be like timing in hour, a minute, etc. Why and how? Okay, what is why and how? Now, why in general is not something that important for the time being here, but in some cases it can be important for analysis. For example, things related to promotion. Okay, so there are sale periods, there is promotion, and why some people buy this thing more and why some people are not buying this thing. Okay, so this may be something that the why answer will give us the type of promotion is there. How means it may be payment, for example. How did they buy? And did they buy using cash? Did they buy using, a credit card, etc.? How, what else can be about how? For example, it can be transport. Let's say extra or IKEA stores, when you buy something, so there is delivery. Okay, so one type of delivery, or even in normal restaurants. So how will say, is it mahalli or safari? Okay, how did he take the order? Is it going to be delivered to the house? Is it pickup, and so on? Okay, so these are the things which are associated with the event. Okay, examples of common dimensions. Now this is the thing. Date is one dimension. Why? Because it's about what, when. Okay, product is about what, customer is who, employee or cashier is who, the facility is the place. Facility means in which store, which area. Okay, so this is where, and so on. So these are dimensions. So it means that for a business process, these who, what, where, when, why, and how, they will identify your business dimensions. Okay, and with the choice of each dimensions, you then list all the discrete text-like attributes that flesh out each dimension. Okay, we will see then after these dimensions, we will see their attributes. Okay, so step 1, identify the business process. Step 2, identify the fact granularity or grains of the fact. Number 3, identify the dimensions, which we can identify here. And 4, identify the facts, the last one. Okay, facts are determined by answering the question, what is the process measuring? Okay, that's important. What do we measure? Measuring means like the quantity. Okay, what is the quantity? The kimia, or like qadar, whatever you call it, but what is the business process doing at the end? What is the outcome in terms of how much and how many? Okay, so business users are keenly interested in analyzing these performance metrics. So these are the performance metrics, as I said, that how much and how many. All candidate facts in a design must be true to the grain defined in step 2. So this measurement should be according to the grain. Okay, facts that clearly belong to a different grain must be in a separate fact table, which means, this is interesting, that you don't necessarily have one fact table. You can have many fact tables for one business process. Okay, or maybe they depend on a different business process. Okay, which has a different fact table, and they may not be according to your fact table. So typical facts are numeric additive figures. Numeric figures, like they are numbers. Additive means we can add them. Okay, additive, like for example, 2 something, 3 something, and 100 something, and 1.5 something. These are numerical numbers which are additive, such as quantity ordered. You ordered something. How many, like what is the quantity? Or the dollar cost amount. Okay, what is the money? So that amount is actually additive, because each item has its own amount. So at the end, you see at the end, for every bill, there are 2 things. They say how many items were there, 20, 25, or 5, whatever, and what is the total count. Okay, so this is there, which is the measurement, or the metrics that we are counting. Okay, so you need to consider both your business users' requirements and the realities of your source data in tandem to make decisions regarding the 4 steps. It means that you need to see 2 things: business user requirements. What are the requirements? Because it depends on the requirements of the business user. It's not what you understand, but it is what is their requirement. The second thing is the source data. So the source data in your case will come, in this case, it will come from the retail point of sale. Okay, what are they recording? So when they scan something, they record what? They record the barcode. With the barcode, there's the product detail, okay? Whether it's the weight of the product, it's the price of the product, it's the color of the product, whatever, it's the company of the product, everything is recorded. So if that is recorded perfectly, very well, then your design will be good. If the data source recording is not complete, for example, let's say they don't contain information about the weight of the product, so maybe you will have a problem later in some analysis, for example, okay? Or let's say there is an example, Pampers, you know, baby Pampers or diapers, okay? They have different like numbers, 1, 2, 3, etc. And number 1 is, for example, from, let's say, 2 to 5 kg. Let's say number 2 maybe from 3 to 6 kg and so on, okay? And for each pack of Pampers or diapers, okay, there is the quantity inside. So one pack may have 5, one may have 10, one may have 100 diapers inside, okay? So this information, if it is stored in the data system, in the database system, transaction system, then you need to record that. If it's not there, then again, you see, this is the reality of your source data is not good, okay? And that will actually create a problem for you. So we strongly encourage you to resist the temptation to model the data by looking at source data alone. No, not just source data. You will also see what is the need of the business, okay? So what we see here in the 4-step dimensional design process, that there is data realities, what things are being recorded, what is available, and the business requirements. Okay, so from these 2 things, we will have a dimensional model, and the dimensional model itself has 4 steps: the business process step, the grain, the dimensions, and the facts. Okay, so I will just pause for a few seconds here and would like to ask you if you understand this, or is there any question, any point that you need to clarify? Further details will come now in the retail case study, okay? There will be actually the details there. This was just an introduction. So we will see the exact details later. Any question? No question. Okay, so no one's now. Okay, good. So what we have next is the case study. Actually, what is a case study? A case study is actually, you know, something which happens in the real environment, and you try to understand that. So a case study means it will help you understand a process in the real world. What are its things that you need to consider for your own, you know, modeling. For example, we are modeling this process of retail, and that is a retail case study. Okay, so here there's some example that imagine you work in the headquarters of large grocery chain, for example, Alotem or Pandas or Bindaut, etc. They are large grocery chain. The business has 100 grocery stores spread across different states. Yes, it's possible. For example, Panda or Carrefour, etc. Each store has a full complement of departments, as I explained to you. Okay, departments: electronics department, dairy department, halwiyat, etc. They may have grocery department, like which has normal things in general, like vegetables, etc. Frozen foods. Okay, this is the things: dairy, meat, produce, which are the vegetables, the bakery items. Okay, floral, which is about flowers. Okay, and health, beauty ads. For example, you know, toiletries and makeup kits, etc. So these are different departments in, let's say, the store. Each store has approximately 60,000 individual products. Okay, in general. Okay, these are from American point of view. I'm not sure here in Saudi Arabia, maybe 60,000 or maybe 50,000 or 80,000, but world standard is around 60,000, for example. Okay, so they are different projects. Each project is known as the stock keeping unit, SKU. Remember this thing, stock keeping unit. okay, which is actually a different product. So for example, like milk, although milk overall is one type of category of product, but every type of milk, like 1 liter, 0.5 liter, 200 milliliter, and then from one company, another company, each one is a different SKU, okay, and it is unique for each type of product. So SKU is identifying a product of one type. But all, let's say Al Marahi is one company, it has a 200 milliliter milk without any flavor, okay, so all 200 milk of cartons, they will have only one SKU because they represent one product, okay. It's not that every copy of that will be different. No, SKU represents one particular product. Let's say 200 milliliter of milk from a company in bottle or in carton, for example, okay. Now 500 milliliter will be a different SKU, 1 liter will be different SKU, for example, okay. So data is collected at several interesting places in a grocery store, okay. So some of the most useful data is collected at the cash registers, remember, okay. So when you purchase something, so at the cashier, there is some data collected, and this is known as the point of sale system, okay. So at the point of sale system, the cashier scans the product barcodes, okay, and it measures the consumer takeaway at the front door of the grocery store, okay, as illustrated in figure 2. Cashier's receipt. So this is receipt, okay, which you can see typically is like this, okay. So this is the grocery store information, the address, okay, the phone number, then store ID, the cashier ID, this is the name, this is the ID number, Alan is the name, and 245 etc is the ID of the cashier. Then this is the ID of the product, okay, you can call it the SKU, stock keeping unit. This is the description of the product, this is the price, okay. This is another one with a price, but you also see there is additional thing, saved 0.5 50 cents of 5.49. So instead of 5.49, you got it on 4.99, so 50 cents is the discount. So this is additional information you can see on this receipt, okay. Similarly here, there is additional information, soy milk quart, okay, and total at the end. So total of these prices, amount given by the person, the customer usually. So they will say, let's say 13, he gave $13, and the remaining amount usually, for example, that will be 33 cents will be remaining, and so on, okay. So this item count also, which is 4 items, okay. Transaction number, the date and the time, okay, and there is a message and there is some unique code, maybe this is a referral code or something like that, okay. So you see, we already know about this. This is an example of output of the retail store activity, the business activity. The input is these products and the output is this receipt, or you see the fatura, okay. So what do we do next? We go next. So from here, what is the business process, okay. Now, so you see, this is a business case study, the retail, and we need to understand this to design the dimensional model. So the first step in the design is to decide what business process to model by combining an understanding of the business requirements with an understanding of the available source data. Remember two things, the business requirements, okay, and the available source data. Available source data comes from the cashier register whenever they scan the barcode, and the business requirements are what they want, the business users what they want, okay. So, so when we start creating dimensional models for our business, so we should focus on the business process that is both the most critical to the business users as well as the most feasible, okay. Feasibility is very important concept, okay. What is feasibility? Feasibility means we consider things like data availability and quality, as well as organizational readiness. What is organizational readiness? If you want to create something for an organization, are they ready to do that? Are they ready to give you data? Are they ready to implement that? Are they ready to buy the things? For example, you may need POS things like those, the barcode readers and those counters, etc. So if the organization is not ready, you cannot do that. Okay, so feasibility means you need to see if it can be done or not. And feasibility contains all those things: data availability, data quality. because if the data quality is also not good, you cannot do that. Okay, and data quality means what is being recorded. So if the store has information about the weight and all those things of the data, then the data is available. But if they don't have any information, then that will be a problem. Okay, so here, the user requirement is what? We see the available source data, it's about feasibility. Then the customer, the management requirement or the user requirement is what? The second thing, the business requirement. They want to better understand customer purchase. Okay, customer purchases, what they want to understand in the customer purchases. There can be many things in that. Okay, so at the end, what we say that the business process you are modeling is POS, retail sales transaction. That's the important concept. The business process is what? The POS, retail sales transactions. Okay, everything you buy, that is a transaction. Now, this will enable the business users to analyze which products are selling in which stores on which days at the end. Now, this is business analytics. Okay, this is the type of reporting or the type of data mining or the type of outcome of data warehousing. That for this example, okay, for this example, we want to know, okay, which products are selling in which stores on which days. So for example, on Friday, maybe let's say on Friday, the people are going to Shifa and the people are going to the parks. So they may be buying things which are different than Saturday, Sunday on the weekend. Sorry, Sunday is not weekend, Friday, Saturday is the weekend, or they may be different than the other days of the week. And this is true in general. You already know this also. Okay, so in some homes or in some families, they have specific days for shopping. And this also depends on things like here in Aswaq al-Othaim, Monday is the day when they have discount. Okay, so some families, they prefer Monday to go there so that they get discount, and that's every week or maybe every 2 weeks, and they wait for the day of Monday to buy things. Okay, so the store selects Monday. Why do they select Monday? Because they know on weekends people go out, they don't have time. So if they reserve weekend for sale, so people may not enjoy sale because they may be going to parties, maybe for weddings and so on. So it's not a good day. Why not Thursday? Because Thursday means weekend is already starting. Why not Sunday? Because it's already start of the week. People are busy in starting their offices and preparing for things. So this is not good. Or maybe they could not sleep on the Saturday because of the weekend. So Sunday is not good. So it means Monday, Tuesday, or Wednesday. These are the 3 days. Then why not Tuesday? Because maybe Tuesday, it's in the middle of the week, okay, too much in the middle, and the people may be already, they have bought something from some other store because at the start of the week they may have shopped. So let's say they say, okay, Monday is good day in which there is a great chance that the people will need something and they will come to the store. Okay, so things like these, they let you decide what is the best time to start offering your products. Okay, and they find this from data analysis. Okay, so Monday is not, let's say, a random date, but they did some data analysis and they found that people will prefer to shop on Monday because maybe on Tuesday or Thursday, we know on Thursday it's Panda. So on Panda, the sale is usually on Thursday. Okay, so if we do also on Thursday, there will be competition and we may not gain much. So Monday is a good day to offer the sale, for example. Okay, so that's the business process. Okay, now let's see the exact detail of the grain. So what level of data detail should be made available in the dimensional model? Okay, so we say that atomic data is highly dimensional. As much atomic. Atomic means, you remember from the database course, atomic means not composite, okay, which should contain only one thing, that is atomic. Okay, it should not combine 2 things, for example. Okay, so the more detailed and atomic the fact measurements, the more things you know for sure. Okay, so atomic data provides maximum analytic flexibility. So for example, weight and size, they are 2 different things. You should not mix them together, so that tomorrow you can have or weight and quantity. let's say weight of an item and the quantity of things in a pack. So I give you the example of, this, uh, again, the Pampers example, okay, diapers example, that they have different size of packs. So maybe you want to know if people want big packs like 100 diapers, or they prefer small packs like 10 diapers in one. Or maybe if it's about, dishwashing, the cloth washing powder, okay, like Tide or Persil or all those things. So do people buy small ones, 2.5 kg or 5 kg, or they prefer 10 kg or 50 kg, something like that, okay? So every information is, if it is atomic, that's good for better data analysis, okay? Okay, so of course, you could declare a more summarized granularity representing an aggregation of the atomic data. Yes, you can have a summary, like for example, instead of saying that I have a diaper of size 10 and 20, you can arrange them into other dimensions, like I say small size and big size and medium size, let's say, okay? Although there may be 10 and 20 and 50 and something like that, but you say, oh no, I don't want so much detail. I would just say they're small. So small maybe 5 and 10, medium maybe 20 and 40, and large maybe, let's say 50 and 100, for example, okay? So you can do that. However, if you select a higher level grain, like large, medium, small, okay, you limit yourself to fewer and potentially less detail, because we lost the details. The details about 5 or 10, etc., is lost if we select the small, the other dimensions, okay? So it's impossible to create details from summary data. Okay, from small, we cannot say whether it's small 5 or small 20 or small 10, for example. So that's not good. The most granular data is an individual product on a POS transaction. Now that's important thing. What is the granular data in POS when you purchase something? It is each product. So each scan is one granularity. Okay, each scan gives you one product, and that is the granularity of the data. Now, what detail is there in each scan? It depends on what you have stored. Okay, you have stored the name only, or the size and other details. Okay, so they may want to understand the differences in sales on Monday versus Sunday. That's what I said. Okay, the business users, they may want to know if more people come on Monday or on Sunday. Okay, they may want to assess whether it's worthwhile to stock so many individual sizes. Let's say there are shirts. So you have small, medium, and large, and XL and XXL, etc. So do you need all of them? Or maybe people, they just want medium and large, for example. Okay, so usually for some types of things like coats, okay, what is code? I forgot the name in Arabic, but for coats, you may have just medium, small, large. But for other types of t-shirts, you may have very small and large and extra large and all those things. Okay, so they may be available. Similarly for shoes, let's say they have numbers from 36 to 42, 43. Now for some shoes, you may like 43 and 36 as well. But for other, you may just have, let's say 39, 40, 41, something like that. Okay. So these types of data will be useful also in knowing like how many shoppers took advantage of the 50 cents off promotion. Okay, so if there is a promotion, there is a discount. So you want to know how many people took advantage of the discount, the impact of decreased sales. Okay, you want to determine that. Okay, when a competitive diet soda product was promoted heavily. So let's say one company, they said Coca-Cola, they say we want to provide a 50% sale on Coca-Cola. So what was the impact of that on Pepsi or 7-Up or other things? Okay, so that is also you can find using the data, because we will have the exact detail of when the sale was started, what was the product, what was the price, and what happened to the other products. So we can compare that. Now, these are the broad questions that require detailed data slice in precise way. Okay, data slicing, you remember, it means that we have specific time period or specific type of product. So we do the data slicing. Okay, so that depends on the granularity. Okay, first question was about the business process, which was the point of sale cashier. The second thing is the grain, and the grain is what? It is the individual product. Okay, now what are the dimensions? Okay, so you can ask yourself or the business users that what are other dimensions they can be attributed to the POS measurement. For example, date of sale, is it important or not? Date can be a dimension. The store is where, okay, so the where is the thing, date is the when, okay. The promotion under which the product is sold, how, was there any promotion or not? So sometimes you have promotion and you need to add that to the receipt. The cashier who handled the sale, and potentially the method of payment. Now, you know, in red tag, for example, okay, in the red tag, they have a system with the cashier in which you give your feedback. So for example, happy face or sad face, so poor or good, satisfactory, very good, okay. So that feedback, actually, when you leave, the cashier will ask you normally, or even if you don't, he or she doesn't ask you, you can click on the button to give the feedback. So it happens recently to my wife, for example. A few days ago, she was buying something, the cashier was not very good, so she just clicked on the poor, and the cashier was surprised because he was not expecting that someone will give me poor, but because he did not behave very well, did not cooperate, and help was not very helpful. So next time he will be careful that yes, and they are not just for nothing. I mean, the company can know that which cashier, which person should be, like, for example, trained because he is poor, or he should be moved from here to some other department, or maybe he should not be given a job at all because he cannot handle the queries. So things like these, they are also can be a part of the dimension, okay, the behavior of the cashier and their points. Okay, so you can add more dimensions to the fact table if these additional dimensions naturally take on only one value under each combination. Okay, we will discuss that, but in general, like, dimensions can be, you see, many dimensions, okay. We will discuss that. The final thing is, after you have the dimensions, you identify the facts. Okay, so what are the facts? The facts must be true to the grain. It must be defining your grain. Okay, what are the facts? They will be according to your grain, and the grain you have selected at step 2. So the individual product line item on the POS transaction in this case. Yes, every product line item, every item is a grain. Okay, so the fact will be about each item. Remember this. Here we mean by the fact that it is measurement about each item. Okay, so the facts collected by the POS, point of sale system, include the sales quantity. What are the facts now? It is the sales quantity. For example, the number of cans of chicken noodle soup. How many cans were sold? That is a fact. Per unit regular price or discount price. What is the normal price per unit? What is the discount price per unit? And the net paid prices. Okay, how much price was paid? For example, usually there is also, the policy that buy 2 and get 1 free. Okay, or buy 5 for 10 real. One is for, let's say, 3 real, and you can buy 5 for 10 real. Now, these types of information, they form the fact, and they should be recorded alongside, okay, in the fact table. So there is some detail. Now, here is the measured facts in the retail schema. So the dimensions we have recorded in step 3, they are the product dimension, the promotion dimensions. I did not discuss that, it's there in the text, but promotion is one dimension. What are the promotion dimensions? For example, is it 5% promotion? Is it weekend promotion? Is it daily promotion? Is it Ramadan promotion, for example? Okay, so these are the promotion dimension. Then payment method, how did they pay? The date dimension, the store, which store is there, and the cashier dimension. So these are dimensions, and these dimensions, you see these 6 are already recorded here. Okay, and after that, the remaining, they are the facts. So for example, the transaction ID, it's actually, a unique identifier for this thing. Okay, and the sales quantity, that's a fact. The regular unit price, the discount unit price, the extended discount, and so on. So this information is unique to each transaction, and that's why it is about sales factor. Now, the product dimension is not unique to each transaction. Every product is different. So one product can be in many transactions. So let's say milk from a company, it can come to different transactions. So that's a product, and that's a dimension. But you see, these things, they are different for each transaction, so they must be in the fact table. Okay. Now there are derived facts, the mushtaq facts, which are mushtaq, but I don't discuss here. There are different types of facts. We don't discuss them here. Okay. Okay. Dimension table details. Okay. Yeah. Let's go to one dimension table details. Okay. Because we now know the facts, but we already know about the dimension table. The date is one dimension, for example. But what are the details in dimension? We know product is one dimension, but what is actually in the dimension table of product? So we need to create a dimensional table. And what type of details do we need? So first we start with the date dimension. That is one dimension. Okay. The other dimensions are here. In this example, the product and the promotion, the payment, etc. These are the other dimensions, but let's start with the date. Okay. And remember the foreign keys, because in the fact table, what you have is that the primary key of date, that will become the foreign key here. We already know this. A primary key here, when it comes as a key inside the other table, that becomes the foreign key. Okay. And DD is actually here the unique identifier for this. I don't remember exactly what is DD, we will see, but this is the description of this dimension for sales fact. Okay. So we study the first detail of dimensional table of date. Okay. So the date dimension is a special dimension because it is the one dimension nearly guaranteed to be in every dimension model. Remember this, because date is present in every type of dimension, whether it's in the hospital, whether it's in the airplane ticket, whether it's in the hotel, whether it's in superstore, whether it's in any travel agent or in the university admission system. So date will be there. Okay. And even we have like date and time to separate. We can combine them together as a single date and time, or we can separately have date and time. Okay, we will see that. So unlike most of the other dimensions, you can build the date dimension table in advance. That's also interesting because we know the dates. If you talk about date, like today is 20th March, tomorrow is 21st March, then you have 22nd March, 2022. You already know that same thing will happen in 2030 and 2050, for example. Okay, so you know that what are the possible rows of date dimension. Okay, now if you consider 20 years worth of days, so it is 7,300 rows almost, because in 1 year this is 365, in 10 years it's about 3,650, and about 20 years you multiply it by 2, so that is 7,300 rows, which is a relatively small dimension table, because 7,300 is 20 years, but you only have this much row, 7,300. It is not a big thing. Okay, so what will be there in the date dimension? You have the date key, which becomes the primary key. Now, what is the date key? We will see about that. Okay, but it is a key which will uniquely identify each date. Okay, then there is the date. The example will come. What is the date? You have full date description. You have day of the week. For example, today is Sunday. That will be there. Day number in calendar month. Day number, what is that? We will see. Day number in calendar year. Okay, day number in fiscal month, which is fiscal month means the financial year. Okay, that's different than the normal year. Normal year is from 1st January to 31st January. Maybe in Saudi Arabia, the fiscal year is also, I think, from 1st January to 31st December. But in other countries like Pakistan, the fiscal year starts from 1st July until 30th June. Okay, they have a different fiscal year. It's different than the calendar year. Okay, and so on. So these are different attributes only in the date dimension. You will see that there are so many things. Okay, and the example of this is here. Okay, the sample rows. So you can see that from 1st of January 2013, then 2nd of January, 3rd January, and so on. Okay, you have a date. Okay, this is the full date description. Day of the week, Tuesday, Wednesday, Thursday, etc. Calendar month is this. You see, these are all about January. Calendar quarter. So there are 4 quarters. January, February, March is 1 quarter. Then April, May, June is quarter 2. July, August, September is quarter 3, Q3. And October, November, and December, this is Q4. Calendar year is there. Fiscal year month. Okay, what is that? The fiscal year is 2013, month number 1. Is it holiday or not? So for example, Tuesday, 1st of January is usually a holiday. Okay. And the remaining, they are non-holiday, for example, let's say, okay, and so on. Okay. And here you can see the date key. Now the date key is simply 2013-0101. Okay, 2013-0102. It's the same thing almost. Okay, they have written in a different way, but it is counted as an integer. And we will see why we have done this as an integer. That's an important thing we will discuss, that how do you design the keys, or these are the primary keys actually for this table. So primary key is not the date, it is not something else, but it is the date key which we generate ourselves. It has nothing to do with the remaining, okay? So this is the date dimension sample row, okay? Then there are some other things which we don't study. You can do that. And we will come to the product dimensions, but after the break. Okay, let's take break for Salah. Just give me 1 minute. Let me stop the recording.